25.
Status check.
Go Atlas.
Go Centaur.
Go WorldView 3.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition and we have liftoff of the United Launch Alliance Atlas V rocket carrying the WorldView 3 satellite for Digital Globe.
Booster has cleared the MLB. Pitch yaw roll program has begun. Vehicle rates look good.
You are hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
RV 180 pump speeds and ejector pressures are within expected parameters. And booster PU is in closed loop control. Pitch yaw roll program's complete. Now flying the zero angle attack phase of flight. Rates look good. Booster engine continues to operate nominally. Mach 1. Max Q. Body rates look good. Vehicle in excellent condition at this point in the flight. And booster is throttled back, right on schedule. Signatures look good. Current altitude is 12 miles, downrange distance 4 miles, current velocity 1,496 miles per hour. Booster is currently accelerating at 2.1 Gs, coming up on stern enable. And closed loop steering has been enabled. Body rates look good. Vehicle is now 50% of its liftoff weight. Currently accelerating at 2.7 Gs. The RCS pyro valve has been firing. System is now pressurizing to flight levels. Signatures look good. Current altitude, 32 miles. Downrange distance, 38.7 miles. Current velocity, 3,943 miles per hour. And Q alpha limited steering has been completed. Booster engine continues to operate well, coming up on our 5G throttle segment. Currently accelerating at 4.5 Gs, and we've begun our 5G throttle segment. Boost phase chill down's underway. Now throttling back to 4.6 Gs in preparation for BECO. Boost phase cooldown's complete. And we have BECO. Engine shutdown looks good. We have retros and stage separation. GN2 purge firings on Centaur are underway. LOX and fuel pre-start are as well. We have ignition and full thrust on the RL-10. And we have payload fairing jettison. Looks like a clean separation. And this first burn of Centaur is scheduled for 11 minutes and 43 seconds. Centaur PU is currently commanding an oxidizer-rich condition as expected for this portion of the flight.
Say again.
RCS line temperatures are warming towards bottle temperatures.
This is Atlas Mission Control at T plus 5 minutes, 17 seconds into today's flight. Marty Malinowski just confirmed payload fairing jettison and all systems continue to operate nominally. Our next event, Centaur main engine cutoff, will occur about 11 minutes from now. And I'm joined now by Neil Anderson, Vice President of Technology Development at Digital Globe. Neil, thanks for joining us today.
Well, thank you, Matt. It's been a great ride so far, and we've been working towards this day for the last 4 years.
So WorldView 3 is going to be the highest capability commercial satellite when it comes to imaging out there. Can you tell us a little bit more about what that means?
Well, we can image with WorldView 3 from 400 miles up in space to 31 centimeters, which is essentially 1 foot in terms of resolution. So from 400 miles, we could see home plate in a baseball stadium. Imagine that you were in San Francisco. With the capabilities of this satellite, we could see home plate in Dodger Stadium in Los Angeles. Not only can we see home plate, we can see the players in the field. And if we knew which teams were playing and what color uniforms they were using, we could tell you which team was in the field and which team was batting. We could even count empty seats and count the people in the field, or in the seats, and if the stadium scoreboard was big enough, we could tell you the score.
Well, I really appreciate the insight into the kind of capability we're looking at with WorldView 3, and I look forward to talking some more about that coming up shortly, Neil. Thanks a lot.
We'll see.
So this is Atlas Mission Control. We're now at T plus 6 minutes, 54 seconds into today's mission. Our next event, the first cutoff of the RL-10 main engine, or MECO 1, is scheduled to take place just about 9 minutes from now. While we wait for the next mission event, let's take a look at video highlighting the important capabilities of the WorldView satellite that Neil just described.
Imagine a world where emergency management teams could see through the smoke of a wildfire to understand the exact location of burn lines, ensuring firefighters are safely dropped into the field. A world where small sharecrop farmers in developing countries could understand their crop health and yield before harvest. A world where oil and gas companies could monitor pipelines for man-made changes in vegetation health, and soil disturbances that are indicators of encroachment. A world where mining management could cost-effectively explore in remote regions and optimize existing production in already developed mines. A world where human atrocities are no longer hidden behind misinformation, but revealed through evidence uncovered in satellite imagery. Digital Globe's industry-leading satellite constellation enables you to go beyond what the human eye can see and start making a world you could only imagine a reality. In 1992, Digital Globe was founded by Dr. Walter Scott, and it was his ability to imagine a world where we could do something better, faster, and more efficiently than what you did the day before that has led us to where we are today. Digital Globe has invested over 20 years in defining and then elevating quality standards in the commercial satellite industry. There is no better source for getting the right answer fast to difficult questions. It all started with IKONOS, which brought high-resolution satellite imagery beyond government entities and into the hands of the everyday commercial consumer. Next was QuickBird, which remains a key part of a constellation of sub-meter spacecraft that Digital Globe has developed that offers highly accurate, commercial high-resolution imagery of Earth. WorldView 1 was the first of Digital Globe's next-generation satellites, the most agile satellites ever flown commercially, allowing the collection of a wide range of targets for customers in a single orbit. GeoEye-1 set the standard for half-meter high-resolution commercial satellite imagery with unprecedented spatial resolution that allows customers to see very fine details on Earth's surface. WorldView 2 offers incredible accuracy, agility, capacity, and spectral diversity, allowing Digital Globe to substantially expand its imagery product offerings. And now, WorldView 3 enters the geospatial realm, the first multi-payload, super-spectral, high-resolution commercial satellite. WorldView 3 is poised to provide entirely new capabilities to customers across many different industries and set a new standard for quality of geospatial data, information, and insight. Today, Digital Globe is able to see any spot on the Earth every single day, where we are creating thousands, millions, or trillions of information points about our planet and helping to solve the world's toughest problems. We call that geospatial big data. Now, imagine that geospatial big data could tell you about how the world is changing day to day by looking at objects around the globe that you are interested in. Imagine a living digital inventory of the surface of Earth that allows you to extract useful information and actionable insights to make informed decisions about your biggest challenges. With WorldView 3 and geospatial big data, Digital Globe is bringing these imaginations to reality. So, what imaginations could we help you bring to life?
This is Atlas Mission Control at T plus 11 minutes, 30 seconds into today's mission. Our next event, MECO 1, is scheduled to take place in a little less than 5 minutes. Right now, let's take a look at some more of the events that led us here today.
Today, satellite imagery is being used by billions of people around the world as a tool for making their lives better.
We began this journey 4 years ago with initial capabilities discussions with Digital Globe.
Well, ULA has had a long relationship and a very successful relationship with Digital Globe.
Every launch is critical, and you cannot take your eye off the ball of that mission success.
Digital Globe's purpose is to see a better world.
We've successfully built a number of satellites for Digital Globe. On orbit are QuickBird 2, WorldView 1, WorldView 2, and then the soon-to-be-launched WorldView 3 spacecraft.
When WorldView 3 is on orbit, with higher resolution and greater spectral diversity and adding to our revisit capabilities, how that will impact not just the news stories, but the events that shape our world.
It's a measure of the pulse of the global economy that is continuously updated. It's a continuously evolving view of the planet, and it's used to answer questions that previously you never were able to answer because you didn't have all the data. Geospatial big data is all the data.
Digital Globe selected the Atlas launch vehicle for a variety of reasons, one of which is because it is the most reliable launch vehicle in the world today.
Our customers depend on this for that reliability, both the mission success and the on-time performance.
As you enter the countdown, everybody knows that in a few hours you're going to be unleashing an incredible amount of energy, and that's all directed to making sure that Digital Globe's satellite gets on orbit successfully.
Liftoff of the Delta II rocket carrying WorldView 1, the most agile commercial imaging satellite ever flown.
2, 1, ignition, and liftoff of the Delta II rocket carrying WorldView 2, the most agile commercial imaging satellite ever flown.
WorldView 3 is going to offer the highest commercially available resolution of any satellite system that's out there. Combining that with the power of our constellation, which gives multiple revisits per day over multiple hours of the day means the ability to monitor what's going on and enabling our defense and intelligence customers to make decisions on the basis of fact, not on the basis of fear.
To see through smoke, to be able to identify specific materials on the ground, to understand the moisture content of the earth or the mineral content. And by doing this, we are able to solve a whole new set of problems.
A complex mission requires extreme partnership to accomplish. And to support our Digital Globe customer required great collaboration between Ball, ULA, Lockheed Martin to meet the Digital Globe need.
This is Atlas Mission Control at T plus 15 minutes, 32 seconds. The WorldView 3 mission lifted off from Space Launch Complex 3 here at Vandenberg Air Force Base, California at 11:30 a.m. Pacific time this morning. The mission is nearing the end of the Centaur second stage engine burn. MECO 1 is scheduled to take place in just a couple of seconds here, so let's go back to Marty Malinowski for the call.
Nominal. Engine performance looks good. RCS line temperatures have thermally stabilized. And we have MECO. Engine shutdown looks good. We have 4S settling on. Fuel tank is being vented down as expected. And Centaur has begun its turn to separation attitude. Fuel tank pressures are stable. Storage bottle pressures look good. This will be a 3-minute, 17-second coast to spacecraft separation. Centaur continues its turn to separation attitude.
This is Atlas Mission Control at T plus 17 minutes, 3 seconds. Liftoff of Digital Globe's WorldView 3 spacecraft occurred at 11:30 a.m. Pacific Daylight Time. Our next event, spacecraft separation, is scheduled to take place in approximately 2 minutes.
And Centaur continues to settle with 4S settling motors, still on its turn to separation attitude. Tank pressures, bottle pressures, and battery voltages are all stable. And Centaur has completed its turn to separation attitude.
This is Atlas Mission Control at T plus 18 minutes, 5 seconds. We're a minute or so away from spacecraft separation. Let's go back to Marty Malinowski.
Centaur fuel tank is being vented as expected. Pressures are stable now. Centaur has begun the spin up to separation. degrees per second. Seven degrees per second. And we have spacecraft separation. Centaur has despun from its separation attitude.
Congratulations, Neil.
Thanks, Matt, and congratulations to ULA for a great ride.
So we talked a little bit earlier about the capabilities of WorldView 3 when it comes to resolution, but what kind of other technologies can we expect from WorldView 3?
Well, let's talk about what it means to be a superspectral satellite. When you take a picture with your personal handheld digital camera, it typically uses 3 bands, maybe 4 bands to give you a color picture. We do the same thing with 9 bands of information. And with the shortwave infrared instrument that we've added to the satellite, we'll actually have 8 more bands for a total of 17 bands. Most of these bands are in fact outside of the range of the human eye, so there's a great deal more information. If we add in the additional sensor that we've added to WorldView 3 for atmospheric correction, we lay another 11 bands down. So when we scan across an area in the ground, we're actually taking 29 separate images in 29 different color wavelength bands. That allows us on the ground to process the data and turn it into all manner of different products for our customers. If we're looking at a forest, for example, we can tell not only that there's a forest, but we can tell you what kind of trees are in the forest. If we're looking at an agricultural field, we can tell you whether what crops are growing, whether they're growing well, whether they're diseased, what the moisture content is in the soil. We can determine man-made objects. We can determine types of roads. We can actually see mineral content on the ground. And with the shortwave sensor, we're actually capable of seeing through haze and smoke. So it's really a powerful satellite.
That's a tremendous amount of capability available for your customers on a daily basis. How is this going to add to the information that's already available to them?
So today, we've been taking imagery since 2000. So we actually have 5 billion square kilometers of data in our archive. Some panchromatic, but mostly multispectral. That is a tremendous source for our customers, but we're going to start adding to it even better with WorldView 3. With WorldView 3, on a daily basis, we can take 4 million square kilometers a day, which is about the size of India. We can't take India all in one day, but it's the equivalent coverage all around the globe. The agility of the satellites, including WorldView 3, is so high that we can maneuver very quickly between targets. If you had a target at 40 degrees north latitude, we can actually see it now 4 times a day. And we can see any target in the globe multiple times during a day. So fundamentally, with all of this capability, we're dramatically adding to the product flow that we can add into our archive and which we can make available to our customers.
So that is an impressive amount of information, Neil. What's next for Digital Globe?
Well, next is getting WorldView 3 commissioned. Hopefully, shortly, we'll have contact with it, and Digital Globe Mission Control will take over. First, we have to check out all the subsystems. So every subsystem has a different set of parameters that we'll monitor and verify. Then we'll turn on the cameras and we'll start taking imagery. And then after that, we'll start to calibrate the whole system so we refine operations and get the best performance out of the system. Once the data is flowing, it'll move into our data archive and start to be used by our product development people to develop even more products or better products than we have today. And ultimately, we're developing a new platform called Geospatial Big Data. You saw that in the video. That will allow customers access to the data, and they'll be actually able to run applications on the platform and develop their own solutions and their own answers. So WorldView 3 is really going to round out the constellation and make it that much better.
Well, Neil, I really appreciate you joining us and sharing all those insights. It sounds like a really exciting time for Digital Globe and now having WorldView 3 on orbit. So thank you very much for joining us today.
It certainly is. We're looking forward to it.
Well, thanks again. And I'd also like to thank Marty Malinowski for his support of today's launch and providing us with the launch vehicle ascent data during the flight of the Atlas V vehicle. For more information about the Atlas V or ULA, you can visit our website at www.ulalaunch.com. You can also like us on Facebook or follow us on Twitter. We'll leave you now with one more look at the liftoff today of the WorldView 3 satellite atop the United Launch Alliance Atlas V rocket for Lockheed Martin Commercial Launch Services and Digital Globe. I'm Matt Donovan, and on behalf of the entire launch team, thank you for joining us and have a great day. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have ignition and We have liftoff of the United Launch Alliance Atlas V rocket carrying the WorldView 3 satellite for Digital Globe.
Booster has cleared the MLP.